Hey guys, so today we are going to start solving quadratic equations. And we're actually going to use our skills from Unit 2 to be able to do this. So we're going to start learning target 5.1, which is I can solve quadratic equations by factoring, taking square roots, completing the square, or the quadratic formula. So we're going to start today with a focus on solving by factoring. As you're watching the video, make sure you're taking notes and writing down all of the examples in your notebooks. So just a few vocabulary words to get us started today. So the first vocabulary word we have is solution or solutions. When we're talking about solutions or solving an equation, these are the values or the numbers that make an equation true. So we're looking to make sure that whatever x value we are getting, it makes the equation we started with a true statement. A zero or a root, these are the values that make any equation equal zero. Kind of makes sense, right, if we call it a zero. These are also the x-intercepts of a graph of the same equation. So if we're looking at a graph and we're asked for the zeros or the roots, we can look for the x-intercepts where a graph crosses or touches the x-axis. Quick reminder that the standard form of a quadratic is ax squared plus bx plus c. Notice now with the equations, we're setting that equal to 0. So a quadratic equation in standard form has to also be equal to 0. And today with our factoring, we're going to use the zero product property, which tells us that anything multiplied by 0 is 0. What this allows us to know is that if one factor equals 0, the whole equation has to equal 0. So we use that idea in some of our steps to make sure we are getting every possible solution or every possible zero or root of a quadratic. So solving by factoring. When we're solving quadratics, we're always finding the zeros or the roots. So even if a quadratic is given to us and it does not equal 0 yet, if we're using solving by factoring as the method we're going to use to solve the quadratic, we have to get it set equal to 0 and in standard form before we can start factoring. When factoring to solve, the quadratic has to be in standard form. Just like when we were factoring in Unit 2, the only way to factor a quadratic, say with the X box or with our factoring by grouping method, was to have the quadratic in standard form. The process. We're going to get the quadratic into standard form and equal to 0 if we need to. Sometimes it will already be like that, but sometimes we'll have to use some inverse operations or some rearrangement to be able to get it in standard form and equal to 0. Then we'll factor the quadratic. We had a couple of different ways of doing that. Sometimes we might only have to factor out a GCF, and that's as much as we can do. Sometimes we might use the X box. Sometimes, like when A is not 1, we might have to use the X box and factoring by grouping, or if you learned the fraction method, that one too. We can always see these with our special case quadratics as a difference of two perfect squares or perfect square trinomials. So all of the ways of factoring that we learned in Unit 2 could be ways that we need to factor here. Once we've factored, we use the zero product property. This again tells us that if one of the factors equals 0, then the whole thing has to equal 0. So we can set each factor equal to 0 and solve. We can always check our answers by substituting it then into the original equation. We always want to go back to the original equation because sometimes we'll make changes to an equation that can make a solution work that wouldn't actually have worked in the first place. So we always want to go back to whatever equation we started with. Let's look at an example. We're going to find the zeros of x squared minus 7x plus 10 equals 0. So let's go through the procedure. Question, is it in standard form? Well, I see my ax squared plus bx plus c equal to 0. So yes, it's already in standard form for me. I don't have to do anything to get it into standard form. So next we'll factor. Since a is 1 here, I will use the x box to factor this. So my a is 1, my b is -7, my c is 10. Using my x box, my a times c, or my c, goes on the top, my b goes on the bottom. What multiplies to get 10 and adds to get -7? -5 and -2. And I know that when I have an a of 1, I can just write out the factors as x minus 5 times x minus 2. And if I'm keeping true to the equation I started with, this would be x minus 5 times x minus 2 equals 0. Next, we'll use our zero product property. So we'll take the x minus 5 and the x minus 2, and we set each of those equal to 0, because we know that if one of them equals 0, then the whole thing equals 0. So I'll have x minus 5 equals 0 and x minus 2 equals 0. From there, I can just solve the equations using my inverse operations, so getting the x by itself. So here with my x minus 5, I'll add the 5 to both sides, so I get x equals 5. And with x minus 2, I'll add the 2 to both sides and get x equal to 2. And then, like a good mathematician always does, we check our work. So taking the 5 and taking the 2, we'll substitute those individually into this equation for x. And we'll see, does that actually make the equation true? So 5 squared minus 7 times 5 plus 10 should equal 0. If we put that into our calculator, 5 squared minus 7 times 5 plus 10 does equal 0. So x equal to 5 is an answer. We'll do the same thing with 2. 2 squared minus 7 times 2 plus 10 equal to 0. Again, you can put this left side into your calculator, and you'll see that that also works. So we have 2 answers to this equation, x equals 5 and x equals 2. Let's look at another example. Example number 2. What are the roots of 7x squared equals -10 minus 37x? Roots, remember, is just another way of saying what are the solutions when this whole thing equals 0. So the first thing we need to say is this in standard form? Well, I know that standard form is ax squared plus bx plus c equal to 0 for a quadratic. So I notice that this is not in standard form because this equal sign is in the middle, and over here, those aren't even in the right order anyways. So I need to get this into standard form. So I'm going to, since I need to move things across the equal sign, I'll use my inverse operations. I like to keep my a's positive. So I'm going to leave the 7x squared where it is. And I'm going to start by adding my bx, or my 37x, to both sides to get 7x squared plus 37x equals -10. Still doesn't equal 0, so I need to move that -10 by adding 10 to both sides. And I'll get 7x squared plus 37x plus 10 equals 0. Now I'm in standard form, so I can factor. Remember when we're factoring when a is not 1, that we need to do a times c, not just c in my x box. So a times c gives me 70, setting up my x box, 70 on top, my b of 37 on the bottom, multiplying to get 70, adding to get 37, 35, and 2. Now remember, we could not just write out our factors as x plus 35 and x plus 2. Since the a is not 1, it's 7. So this is where we set up the problem for factoring by grouping. So we took this 37x in the middle, and we split it up into 35x plus 2x. And then we were able to start factoring by grouping. So here you see my 35x, my 2x. Those together would give me that 37x. Setting it up for factoring by grouping, in my first group, I can factor out a 7x. In my second group, I can factor out a 2. Both of them give me x plus 5, which is exactly what we want, right? Those parentheses have to be the same. So my factors are 7x plus 2 and x plus 5 equals 0. From here, we'll use the zero product property. So set each factor equal to 0 and solve. So I have 7x plus 2 equals 0 and x plus 5 equals 0. Remember, we want to get the x completely by itself. So starting with my subtraction for both of these, since there's addition, I'll subtract 2 from both sides on the left for my 7x plus 2, and I'll subtract 5 from both sides on the right with my x plus 5. So on the left, I have 7x equals negative 2, and then on the right, I have x equals negative 5. The x equals negative 5 is done, but there's still a 7 with my x. 7x is 7 times x, so I'll divide by 7, and I'll get x equals negative 2 sevenths. So I've got two answers again, x equals negative 5 and x equals negative 2 sevenths. So now I need to check my work. When we check, again, it's very important that we go up to the original equation. We want to make sure that this original equation is true. Sometimes it'll work here. A solution will work here, but won't work in the original equation. So we need to make sure we're being careful with that. So always go back to your original equation to check. So we'll take my negative 2 sevenths and we'll take the negative 5 and we'll substitute it and make sure that the left side does actually equal the right side. So by substituting 7 times negative 2 sevenths squared, I would just put that in my calculator, see what that equals. And then for my right side, negative 10 minus 37 times negative 2 over 7, I would put that into my calculator, and those should give me exactly the same decimal. I would then do the same thing with my 7 times negative 5 squared, making sure that is the same thing as negative 10 minus 37 times negative 5. Those both work out, which tells me that both of these answers are correct answers. One more example before we move into some practice. Example 3. I wanted to do this example because it does not use the X box. So I want to make sure we're also thinking about other possibilities of leading to factor equation. So this one is asking us, what are the roots of x squared minus 3x equals 0? So we're going to go through the procedure exactly the same way. We're going to say, hey, is it in standard form? Well, yeah, it is, because there's the ax squared plus bx. I just don't see a c. So when I factor, I'm no longer thinking about using the x box because I don't have a c. There's no constant. There's no number by itself. But what I can do is factor out a greatest common factor. So here for this problem, my greatest common factor, if you think back, would be x. So I can factor the x out, and I'll have x times x minus 3 equals 0. Then again, we can use the zero product property. So I'll set my x, which was outside here. That x needs to be equal to 0, and the x minus 3 is set equal to 0. X equal to 0 is already done. My 3's, I would add x minus 3, I would add 3 to both sides, so x would equal 3. And then again, we need to check. 0 squared minus 3 times 0, that does equal 0. 3 squared minus 3 times 3, well, 3 squared is 9, minus 3 times 3 is 9. That will also equal 0. Both of those check out. So both x equal to 0 and x equal to 3 are correct answers.